Hey all, we did have an introduction to writing two-column proofs, but I just wanted to do a little bit more here and show you some different types of proofs you might encounter. So you're always going to be given some information in a proof, and you're always going to be asked to prove something. Typically those proofs come along with a diagram, and those diagrams may or may not have some congruences marked on them. So my advice is to always mark the pictures up with what you know that you're given, and also with things you know because of things like vertical angles or reflexive property, um, midpoints, things like that. Once you mark the picture up, you have an idea of how your proof should flow. So I'm going to mark up what I know here. Angle LMN right there is congruent to angle PNM right there. Angle LNM and PMN are right angles. So LNM, that's a right angle. PMN, that's also a right angle. And then now we should know from practice that we have a reflexive property scenario here, so we can mark this. So what we've been working on is marking up pictures, deciding what theorem proves that they're congruent. So if we were answering that question, we would know these two things are congruent by angle, side, angle. So our goal in our proof is to show that two pairs of angles are congruent, one pair of sides is congruent, and then we have angle, side, angle congruence. So we're going to have our statements and our reasons. Our first statement is always the information we're given. And then the justification or the reason is that you were given that piece of information. So let's just copy that down. And now, knowing that these two angles are right angles, we know that they're congruent. It's something that we know to be true. But in order to write a formal proof here, we need to state that those two angles are congruent. So I'm going to say that angle LNM and angle PMN are congruent angles. And I can justify that by saying right angles are congruent. So now if I'm keeping track, I've stated that this one pair of angles is congruent. This second pair of angles is congruent. And my goal was to have angle, side, angle. So now I need to say something about the sides that are congruent. And it's that same side in both triangles that I know is congruent by reflexive property. So I'm going to say that. Side MN or segment MN is congruent to segment MN because of the reflexive property. So now I've got my two pairs of angles I've shown to be congruent. I've got my pair of included sides that I've shown to be congruent by the reflexive property. So now I can conclude that the triangles are congruent by that theorem I had in mind all along. They're congruent by angle, side, angle. And sometimes when you're trying to prove something, it's not always that the triangles are congruent. You want to maybe prove that pieces of them are congruent. So in this example, I want to show that angle K and angle N are congruent. So I might, as just a display to myself so I know where I'm heading, I might circle those angles. Now I have an idea of what it is I'm trying to prove. I want to show that those two angles are congruent. We started this unit by talking about if we know two triangles are congruent, then we know the parts that go together are congruent. So if we know that these two triangles are congruent, then we can say angle K is congruent to angle N. And it was that long statement that we said we'll reduce that to CP/CTC, or corresponding parts of congruent triangles are congruent. So long story short here is I want to show that these two triangles are congruent, and then I can say that the pieces in the triangles are congruent. So let's see what we know here. L is the midpoint of JM and NK. So if I know that L is the midpoint of a segment, that means the two pieces of the segment it makes are congruent. So JM, if L is the midpoint, that means that JL and LM are congruent. If L is the midpoint of NK, that means that NL and LK are congruent. And we know from experience that those two angles are congruent because they're vertical angles. So it looks like we can show that these two triangles are congruent by side angle side. And then if those two triangles are congruent, then those two angles K and N are congruent. So now let's write that up formally. Always start with our given information about L being the midpoint. The thing we know as a result of L being the midpoint is that those... Oop, I went out of order, sorry. I'm going to skip here. Oops, I even skipped a step. Well, this is a good example of how we have to justify everything. So I skipped a step here. As a result of L being the midpoint, I need to say that JL and LM are congruent. I'm going to pause and type that. So I apologize for the mistake, but it happens to the best of us. From knowing that L is the midpoint, I know that these two pairs of segments are congruent. The definition of a midpoint is that it's directly in the center and it makes two congruent segments out of the original segment. So L being the midpoint means that each of those pairs of segments are congruent. Now I can say something about the vertical angles. And it would have been okay for me to say the vertical angles thing first, but I like to take my given information and then write about what that means for us right away. So I'm going to state that those two angles are vertical. Now I have two pairs of sides congruent, one pair of angles. I can say those triangles are congruent by side angle side. We're not done because I want to prove those two pieces are congruent. So I have one more step, and it's to say that K is congruent to N because corresponding parts of congruent triangles are congruent. I've got a couple more for you here. Sometimes our triangles overlap, and that's okay. We can still use the same methods. I still want to mark up my picture with what I know. I know that angle A is congruent to angle C because I'm told. I know that AB and CB are congruent. And also I have this angle B in both of the triangles. And we have a reflexive property scenario here. So it looks like if I outline this triangle, ABE, I have an angle side angle scenario. Same is true if I outline this triangle, CBD, angle side angle. So I'm going to show these two triangles are congruent by angle side angle. I start with my given information, which tells me about one of the angle pairs that are congruent and the side pair that I need. So all I really need to state now is about angle B. Angle B is congruent to itself. Oops, I'm having a day here. Angle B is congruent to itself because of the reflexive property. And so then the two triangles are congruent by angle side angle. So kind of a quick proof, but it was difficult for the reason that these two triangles overlap. Some advice I might give you would be to maybe redraw the triangles separately. So sort of pull them apart, label each vertex, mark the pictures up like you would. That might make it easier visually to develop your proof. So one other way we might want to prove that triangles are congruent would be in the coordinate plane. And so there's not a ton we can do about angle measures in the coordinate plane. The only thing we can do about using angles is if we know they're congruent. But what we can do is find out how long sides are. So we're given here that angle C and angle F are congruent. So we can mark that. And then we're not going to be able to develop anything else about the angles. But what I can do is I can show that AC and DF are congruent by finding out how long they are. And I can show that BC and EF are congruent And we find out how long they are by doing the distance formula. Or what we did was Pythagorean Theorem earlier this year. So I've written down the coordinates for all the points. There's my Pythagorean Theorem. And remember that C is the thing that we're looking for. C represents the length or the distance we're looking for. So if we isolate C, it's just this a squared plus b squared square rooted. To find A, we figure out how far apart are the two x values. To find B, we figure out how far apart are the two y values. So I'm going to start with my given information, that angle C and F are congruent. And then I'm going to use my Pythagorean theorem to figure out how long AC and DF are and how long BC and EF are. So for AC, the x values of A and C, -7 and -5, are 2 units apart. The y values 8 and 3 are 5 units apart, and so I plug 2 and 5 in here for a squared and b squared to get AC to be the square root of 29 long. In DF, the x values for D and F are 2 units apart. The y values for D and F are 5 units apart, giving us the same result, the square root of 29. Similarly, the x values for B and C, -1 and -5, are 4 units apart. The y values for B and C, 6 and 3, are 3 units apart. So I'm going to plug 4 and 3 in here and figure out that BC is 5 units long. For EF, the x values 8 and 4 are 4 units apart. -1 and -4 are 3 units apart. Plugging in 4 and 3 and getting 5 for EF. So I do have 2 pairs of sides that are the same length. And I can justify that by saying I use the distance formula, or in our case Pythagorean theorem. They're both the same. And so from that, I can say that these 2 pairs of sides are congruent. The definition of congruence are things that are the same size and shape. And so now from my given information, from all this work, I have 2 pairs of sides and 1 pair of angles included that are congruent. And so I can say those triangles are congruent by side, angle, side. So what we've done here is sort of marry 2 concepts, our distance formula from earlier in the year and congruent triangles that we've been working on lately to write a nice proof. So that's all I have for you today. If you have any questions, make sure that you ask, and I'll be sure to help you out.